Hello, we are going to talk about MRA, brain axial section, or MR, magnetic resonance angiography. This is called MRA axial section. So if we started from this, and this is the skull, enclosing the arteries of the brain, please, when you start mentioning the arteries of the brain, try to remember always the right and left vertebral arteries. The right and left vertebral arteries will enter the foramen magnum. This is the right vertebral artery, and this one is the left vertebral artery. This will unite to form what's called the basilar artery. Let's see the basilar artery is number 14 here on the MRA picture, and on our model, it will be this one here. Okay, so this is the basilar artery. The basilar artery will split or divide into two. This is the left posterior cerebral, and yes, this is the left one, because the MRA orientation will be like this. It is reversed one. So remember always that the left supposed to be right and the right will be left, but this is how to read it. Okay, so this is the left posterior cerebral artery, but we have still anterior and middle cerebral arteries. From where will they come? From this big artery. This is the internal carotid artery that always gives no branches in the neck and will come to pass through the cavernous sinus, and then will give this artery here. This is what's called the ophthalmic artery. Okay, and after this we'll give the anterior cerebral artery. This is the left one, and middle cerebral artery. Remember always that the internal carotid artery, this one, is linked to the posterior cerebral artery by what's called posterior communicating artery. This one here, and it's illustrated as you see here. This is, we have this one is the left one, and this one will be the right one. Okay, we will go deeper to read what's called anterior cerebral artery right one and the anterior cerebral artery are connected by a small branch here called the anterior communicating artery. The anterior communicating artery here is very, very small, okay? And it is number 3 here. As you see, it is very small. So when I asked you, what are the branches of the cerebral circle of Willis or circle of Willis, that if there is an aneurysm of the circle of Willis, will rupture lead to what's called subarachnoid hemorrhage. Okay, so we have the clinical importance or significance of this one. We have subclavian steal syndrome of these arteries, and we have also the subarachnoid hemorrhage. Okay, so if you remember that the circle of Willis, which is this one, it is not circle, it is just a semi-diagonal section like you see here. What are forming it? Let's see them. This is the communicating one, anterior communicating artery, and this is anterior cerebral artery, the left one and the right one. Also, we have internal carotid artery, left one and right one. So half of the circle will be completed by one communicating artery, right and left cerebral, anterior cerebral arteries, right and left internal carotid, and right and left posterior communicating, right and left, okay, or left and then right. And we have the posterior cerebral arteries too. So anterior cerebral artery, anterior communicating artery, internal carotid arteries, and posterior cerebral artery, right and left, and posterior communicating arteries. And this is the circle of Willis. We can draw it for you to see the last picture of it, to remember by our diagonal section in this axial MRA. So this one will be here. All of these is a circle of Willis. As you see here, this is the circle of Willis here. Okay, it is not circle as you remember, it's just a shape, and it will be like this. So we have the branches here. If you just remember with me, we have this anterior communicating artery, we have right and left anterior cerebral, we have the internal carotid here, and we have posterior communicating, and this is of course both sides, posterior communicating, and then posterior cerebral as you see here. So this is the circle of Willis. Thank you very much. I finished. I need you to just remember all of these branches in your mind if it's asked. Thank you so much.